Rain is falling, leaves are changing color, and it's time to start thinking about what's going to be happening in the upcoming winter. I'm meteorologist Tanis Leach talking to you about what's going to be happening in the upcoming winter here in the Willamette Valley. This is the technical version where I will go over all my methodology. Yeah, however, I did leave a few minor portions out that I felt would be too bloated for this video. I have attached my entire 25-page written report in the description below if you want to read that. I do have one bit of housekeeping, and that is that PNW Weather 101 will continue as a monthly series. I do plan on releasing it on the 3rd of every month. However, there may be times that it cannot be released by the 3rd because I'm on vacation or for whatever reason, so I might delay it on some months. Also, my yearly disclaimer. This is a long-range forecast. This is intended to provide a general sense of what may happen in the coming months. It is not that this is for sure happening, nor is it an excuse not to be prepared for any winds, snow, or ice storms, or any cold temperatures. Right, now that that's out of the way, I have one update for my scorecard from the previous video I made in April with said scorecard, and that is I previously projected both my October and December forecast to be a forecast miss for the water year. However, because of the dry spring and summer that we experience, that made the December forecast into a forecast hit instead. 39.9 inches was our water year versus my forecast in December was 33 to 41 inches for the water year. Everything else is the exact same from said April video. Now, onto my methodology. I use an adjusted analog year approach using ENSO via the Oceanic Nino Index and confirmed using the Southern Oscillation Index. I also use the Pacific Decadal Oscillation. New for this year, I am using the Quasi-Biannual Index, at least on experimental basis. I also take a look at the sunspot count, mainly to confirm what ENSO state we should be in. And then analogs are also not weighted equally. Analogs closer to this year's condition-wise will have a higher weighting. I can also make adjustments to analog years using statistical analysis. If there's a statistically likely or unlikely chance of something occurring, I will adjust said analogs unless if there's a clear trend in the analog years showing the opposite for the final forecast. I will also take a look at general trends based on the previous season when appropriate. Snow before the 1970s have been adjusted to a 4.3-inch average per winter on analogs, which has been the average we have experienced here in the Willamette Valley since the 1970s. Temperature departures have also been adjusted to averages at the time which they occurred. So, for instance, if we're using 1925, for example, I'm using the averages that were taking place at 1925, not the current 30-year normals. All forecasts will cover what has happened in 1 out of 3 winters at the Portland airport, and analogs will now go back to 1872 now that I have my hands on reconstructed ONI data going back to the 1850s. For analog years before 1940, I used Portland downtown data, taking the raw temperature from there, adjusting for temperature departures to said decade. But for rainfall, because downtown Portland averages about 7 inches more than the airport, I take it as a percent of normal and then convert it into the airport's total from there for that chart later in the video. Onto our data and oscillations, and I'll start with the ENSO outlook from the US's models with a few global models sprinkled in on the left chart here. So most of the models are showing either a cold ENSO neutral or a weak La Nina, with a few dipping into the moderate La Nina territory. CFS also generally agrees with this, with a large cluster of their ensembles in that weak La Nina territory, with a few of their ensembles dipping further into the moderate La Nina territory. Taking a look at the world's outlook, and this is a 1 month anomaly for December rather than the 3 month anomalies that NOAA looks at. And NOAA's model is the most aggressive out of the global models here. And for December, minus zero point 0.8 Celsius is the global average, which Generally speaking, that's borderline weak La Nina or ENSO neutral. Now, you need 5 3-month periods of half a degree Celsius or lower for that to be classified as a La Nina, and this month has the highest temperature departure from normal modeled. All the other months are closer to ENSO neutral. Looking at the ocean temperatures, however, shows that a La Nina is developing, especially in that central Pacific, and then looking at that subsurface temperature anomalies. Those colder anomalies have come closer to the surface than they were in April, but they still extend down 150 meters into the ocean. Taking a look at major windstorms and ENSO, almost all of the major windstorms in the Pacific Northwest have occurred during ENSO neutral years, with a few of them occurring during weak La Ninas and weak El Ninos. There have been no major windstorms in the Pacific Northwest during strong El Ninos or strong La Ninas or moderate of either strength. And because we're most likely in either a weak La Nina or a cold side of an ENSO neutral, that heightens the odds of a pretty significant windstorm. That's before looking at the analog years. What happens during these ENSO states other than that? ENSO neutral, pretty much average, almost across the board. Median snowfall, almost at the long-term median of 2.6 inches. Average temperature departure, just a titch below normal. Median lowest temperature at 19 degrees. Typical mountain snowfall. The one exception, the water year rainfall median, 4 inches below average at 32.5 inches at PDX. This is lower than any El Nino state, contrary to popular belief. Weak La Ninas is the snowiest ENSO state with a median of 7.3 inches after adjustment. Average temperature departure is 64 hundredths of a degree below average, with the median lowest temperature of 17 degrees. The water year rainfall median is about an inch and a half above average. I will note, however, that the driest water year was a weak La Nina. 115% of mountain snowfall, well, on average, results in a weak La Nina. Southern Oscillation Index in the last 5 years, and the SOI wants to push into that positive territory based on trends from the previous 9 months, but it hasn't been able to do so yet and is still in the neutral phase, at least for now. PDO the last 5 years, firmly in the negative phase. For that would enhance any La Nina-like conditions we would experience, or if it stays ENSO neutral, would tilt the atmospheric conditions towards La Nina. AMO. I've used this every year I've done these long-range forecasts and posted them to YouTube. However, for this year, when I was getting my data, this was the page I was met with when getting set data. The AMO dataset has not been updated since January 2023 because the Kaplan SST dataset has also not been updated, and the AMO relies on said dataset. So I decided to leave it out this year in order to reduce any forecast error, even though it is a fair assumption it is still in the positive phase. Now, onto our new oscillation this year, the QBO. QBO is on average a 27-month cycle measuring winds between 10 millibars and 100 millibars in the upper atmosphere, divided into two phases. One westerly phase produces heightened odds of below normal temperatures, deep Arctic blasts, and slightly higher than normal precipitation. The easterly phase tends to produce above normal temperatures and slightly below normal precipitation. There is an increased chance of sudden stratospheric warming events, which recently the Portland area has done pretty well with that, followed by wintry weather within the 2 to 3 weeks following it. However, there has not been significantly deep Arctic blasts caused by these sudden stratospheric warming events. They've all been pretty shallow for the few blasts we have gotten from them. It is slightly more often in the westerly phase, but the easterly phase does tend to be stronger. Also, some meteorologists believe the QBO is the most predictable oscillation out there, because as you can see here, it's pretty consistently 27 months, and you can tell that, okay, About 40% is going to be in the easterly phase. That's shown by the white colors. 50 to 60% will be in the westerly phase. Those are these darker gray colors. Taking a look at the bottom right, and you could see from 70 millibars on up to 10 millibars, we are now in the westerly phase up there, and very soon we'll transition to the westerly phase in that lower part of the upper atmosphere. Sunspot count, we are approaching that solar maximum if we haven't hit it yet already. That tends to favor either ENSO neutral or El Nino rather than a La Nina, so that could dampen the strength of a La Nina that could result. Looking at our analog years here, and I have 23 analog years that I have posted here. All of these analog years are either La Ninas or ENSO neutral years that followed a moderate or a strong El Nino. So what happened during these analog years? I'll start with 1886 to 87 because this was the best PDO fit of my analog years, with it being firmly in the negative phase then. La Nina strength was moderate, however, compared to our most likely weak La Nina or cold, very cold side of ENSO neutral. 1915 to 16, PDO flipped to the negative phase and stayed in the negative for years to come, while the ENSO state was super cold neutral, and I say it that way because it did reach into La Nina conditions, but not for the required time period for it to be classified as an official La Nina episode. For the years since 1950, 1966 to 67 had a cold neutral year where conditions may have briefly dipped into La Nina territory, but nowhere near long enough for it to be classified as an official event, with a neutral PDO tilting negative. 1992 to 93 had a ENSO neutral year, pretty much purely neutral. PDO, however, was positive. 2016-17 was a weak La Nina that deteriorated into ENSO neutral as the winter went on, with a neutral PDO. All of these analog years were transitioning into the westerly phase in the QBO, with 1992 to 93 having the best QBO fit of the analog years. For the extreme events, 1886 to 87 had the second warmest December day downtown at 65 degrees on the 13th. I also find this day particularly interesting because it was bone dry that day. It's not due to an atmospheric river, which normally that's required in the months of December or January to get to 60 degrees or higher. But once that calendar flipped into February, winter was on. Early February had a major Arctic blast, with February 3rd in particular having a high of 16 degrees in Portland. Low of 9 degrees occurred the next morning. 6 days in a row failed to get above freezing, and 11.4 inches of snow fell during that blast alone, plus an additional 7.5 inches in more marginal setups later in the month. In 1915 to 16, there were two major Arctic blasts, with Portland's January average downtown being the fourth lowest in recorded history. In that first blast in early January, there was 7 days in a row where highs didn't get above 30 degrees, where there was also 11 inches of snow and change at Portland versus 6.7 inches in Eugene. I will also note that that winter was the second snowiest winter on record in Eugene. However, a lot of their snowfall that winter was due to more marginal setups that likely wouldn't happen in today's climate. Late January to early February, another 7 days failed to get above freezing in Portland, with 26.8 inches of snow plus unknown ice and flooding in a transition event that got Portland out of that Arctic blast. Eugene dodged most of this blast. However, there was one day where they got 7.3 inches of snowfall and failed to get above freezing that day. March 4th, 1916, however, winter came back with a vengeance in Eugene with 10.7 inches of snow, their third snowiest calendar day on record, and their snowiest outside of January of 1969. I will note that that probably wouldn't happen today because of the marginal setup that resulted. Hyperactive water year, 56 inches and change in downtown Portland and almost 56 inches in Eugene. Hyperactive water year is the top 10% of water years. That's 47 inches or more at the Portland airport, 52 inches or more in Eugene, and 56 inches or more in downtown Portland. The following events happened during the 1966 to 67 winter. Moving swiftly on, 1992 to 93 was a pretty active winter with 14 inches of snowfall at PDX, 18.2 inches in Eugene. I believe it was also Salem's snowiest winter on record as well. There was snow recorded in every winter month, that's December, January, and February, with February containing the 1 day calendar record until February 22nd, 2023 broke it. It was also the last day that both Portland and Eugene saw 5 inches or more on the same calendar day. January was a minor Arctic blast in the southern Willamette Valley, where Eugene bottomed out at 8 degrees. There was also the Inauguration Day windstorm in the Puget Sound, which was a strong but compact windstorm. Eugene had a hyperactive water year with over 63 inches of rain falling there. 2016 to 17, pretty active year. Most active since 1995 to 96 with 4 separate snow and ice events in Portland. There was also a few windstorms, most notably a windstorm in April with a peak gust of 56 miles per hour. This windstorm also was pretty compact with the peak damage was in the Willamette Valley, even though it didn't cause that much damage for the wind speeds and how saturated the ground was because of how hyperactive the water year was. 51 inches and change of rainfall at PDX. Moving on to our charts for the water year rainfall, and I did notice this year for my analog years there was 3 significant clusters. One from about 32.5 to 34.5 inches, second from 37 to 39.5 inches, and a third from 44.5 to 47.5 inches, with not a lot of in between and a few outliers above that and only one below those clusters. The overall median was 38.34 inches, top analog median of 44.76 inches, and my weighted formula came out to be 41.32 inches. In Eugene, my median was higher, 47.97 inches in my analog years, top analog median of 51 inches, and the weighted formula came out to be 50.66 inches. I will also note that the top analog years all came out to be above Eugene's average of 40 inches and change, and of the 23 analog years that I have, only 5 were below that average. Of those 5 below average, 3 of them were within an inch of that average. Temperature departure from average. The overall median was about 84 hundredths of a degree below average, with the top analog median being significantly colder, 2.5 degrees below average, with 2 top analog years being extremely cold winters of 3 degrees or greater below average. However, there was one top analog year that was 3 degrees or warmer above normal, and then weighted analog median of about a degree below average. In Eugene, overall, it was generally speaking closer to average than the analog years in Portland spat out, with 14 hundredths of a degree below average being Eugene's median, top analog median of about 1.7 degrees below average, and the weighted formula came out to be a degree below average. Lowest wintertime temperature or at PDX or downtown Portland when appropriate. The all analog median was 13 degrees. Top analog median was 13 degrees. Weighted analog formula was 13 degrees. This chart made me very happy as it made my forecasting job pretty easy. There was a big cluster in that lower teens range, especially from 11 to 13 degrees. In Eugene, was pretty similarly easy to forecast this one. Median of 14.5 degrees, top analog median of 14.5 degrees, weighted analog formula 14.5 degrees. Snowfall in Portland, Overall median of 3.6 inches, with my top analog median being at 11.2 inches and the weighted analog median being at 9.6 inches. In Eugene, the overall median was 3.7 inches, top analog median of 11.7 inches, with the top analogs having the only two winners in my analogs containing more than 12 inches of snowfall. And then the weighted analog formula came out to be 11.5 inches. I will note for Eugene, because there was no snowfall measurements being recorded between the winners of 1996 and 97 to the winner of 2012 to 2013. I did not include those years in calculating the median, top analog median, or the weighted analog formula. So let's go to our statistics. 9 consecutive winners have had measurable snowfall in Portland. This is a record high. Chance of a 10th occurring, unadjusted, is 3%. I found no significant change between adjusting my snowfall and not. I will note that this is possibly overwritten by La Niñas almost always having snowfall, because of the three La Niñas in Portland that didn't have snowfall, all three of which were strong La Niñas, two of which were in the snow drought in the mid 1970s. Only three winners have produced a temperature under 20 degrees with less than an inch and a half of snow. All three of them had zero snowfall. All but one of the moderate or strong El Ninos that was followed by a La Nina winter produced an Arctic blast. Last year was a strong El Nino. This year, a weak La Nina is slightly favored. Pretty good odds for an Arctic blast, I would say. All but one of the moderate or strong El Ninos that evolved into a La Nina the following winter had the La Nina water year wetter than the El Nino water year. For reference, 39.9 inches was our water year in Portland. That also is pretty close to that threshold for the top third of water years, which that cutoff is 39.7 inches. Even when I'm including the rest of my analog years in that data set, only 3 of the 23 were less than the year before, and 2 of those were within an inch of the previous water year. Both of those years that were added were the years that were within an inch and were ENSO neutral years. So, all that taken care of, let's get on with our predictions. I will start with the basics. Rain, I'm predicting above average this year, with a hyperactive year being possible. For Portland, I'm predicting 39.9 inches or more, with a best estimate of 46 inches. For our friends in the South Valley, I'm predicting 44.2 inches or more, with a best estimate of 51 inches. Only an inch below hyperactive categories for both locations. Temperature departure below normal temperatures are favored. My best estimate in Portland's 2 degrees below average, and the southern Willamette Valley 1.5 degrees below average. Windstorms, I do expect a decent windstorm somewhere in the Pacific Northwest this year. However, it is entirely possible that it may be compact enough that the Willamette Valley dodges it, as I have noted with my top analog gears. Extreme events. Lowest temperature departure, or below 20 degrees, I expect that lowest temperature to be right around 13 degrees as my best estimate. An enhanced chance of an Arctic blast, for in simpleton terms. Most likely to be active, I expect that to be the latter half of winter, specifically from January 1st through February 15th. In the snowfall department, mountain snowed up on April 1st, greater than 125% of normal. For areas above the ski area's base elevations, 115% or better. This is a great year to get season passes if you haven't done so already, or try skiing if you want to learn a new sport this year. So, on to valley snowfall. Potentially hyperactive, 6 inches or more. The hyperactive cutoff in the Willamette Valley is 12 inches. That's also a top 10%, in this case, snowfall year. Portland, my best estimate is 9 degrees. In the South Valley, my best estimate is 11 inches. And then chance of a no snow winter is at 20%. And then I have one additional prediction this year, and that is going to be things winter will never do. In order to prevent a copyright strike, at least as much as I can, I will not be singing this, nor will I be including any audio. Those of you enshrined in pop culture will know what has just happened. So, that is it with my forecast. I did present this exact forecast at the 32nd annual Winter Weather Forecast Conference hosted by the Oregon AMS. When those presentations go live for the other forecasters, I will link those in the description. When this video goes live, I'm also linking the full 25-page report that I wrote up on top of this video. Otherwise, I will see you all most likely for PNW Weather 101 and my updated forecast in December. So stay safe out there and take care.